Hi, everyone. Welcome to Citrix Converge 2021 session about MCS custom properties. My name is Yuhua. I'm the Director of Product Management. My ownership is on the Citrix provisioning, basically PBS and MCS. And this session, I'm going to be talking about MCS custom properties. The agenda is going to be first introduction, and then I'll go deep dive on each of the platform where we have custom properties. So first of all, what is custom property, right? For provisioning, it is a method to specify properties of a VM on a per hypervisor basis. It is in a simple XML format with a list of names and value pair. It is defined per MCS prof scheme, also known as a catalog. It is stored in a database and copied to each VM as a configuration parameters. So it basically means every VM actually had a custom property itself. There's a global custom properties, and then every VM had a copy to it. In terms of the name value pair, if the name is unknown, it will be ignored for now. We're working on enhancing that to basically provide the feedback, right? If the name is unknown, we'll give you feedback in terms of, hey, it could be a typo. So we will remind you that this name is wrong instead of current behavior, which is silently accept and not acting on it because it's unknown. And right now it's a case sensitive, but we are also making changes so it will be a case sensitive. And at the bottom, you can see an example of our custom properties. Currently, the custom property is opaque data in the Citrix SDK developers website. So this is actually the first time ever we talk about custom properties. We are in the process of documenting it properly and release that to the SDK website. So stay tuned for the official publish of that documentation. So this session is both as an introduction as well as go deep dive into the behavior and the purpose of the properties. But then later when we publish, you will see all those information. Maybe not as detail as what I'm going to talk about it, because I will talk about both the property as well as what we are, what we plan to do. Okay, so let's start with Azure. So first is Azure Storage. Now, in terms of Azure Storage, because we have different disks on a VM, right? We have the OS disk, we have identity disk. We also have a choice of MCSIO, which we call it write-back cache disk. So each of those disks, you could set the storage type for it. Starting with storage account type. So this is default. And if you set the storage account value, then it will be the same as, if you don't set it, it will be the same as the OS disk. It will be replaced by storage account storage type, because storage account type was sort of for the historical reason, because that was the name in the past. Now that Microsoft moved away from storage account into recommending the managed disk. So we are going to change that from storage account type to storage type. So we're going to deprecate that the storage account parameter. But for now, that's the one that is to be used. And then we also have an identity disk storage type. It's default to standard SSD, because that's the cheapest option. We don't see a reason that you need to change. You need to choose a different one, but the option is there. You could change it to other disk type as you wish. And then lastly is write-back cache disk storage type. Is default again, same as OS disk of the master image, but you could change that if you want to. There's 3 possible values: standard IRS, standard SSD LIS and premium LIS. Roughly, they are double at each tier, right? Standard SSD is double of the standard HDD, and then premium is double of the standard SSD. And they also, keep in mind that they also have a different starting size from a billing standpoint. So they're not starting from the same size. For example, you can find that information from Azure website. So continue on that storage account. Even though Microsoft is moving away, and we also follow Microsoft recommendation, also moving away from storage account and leaning towards moving forward using managed disk, because all the new features, frankly, are all built based on managed disk. But there are still customers who prefer to use unmanaged disk. For those customers, these are two sort of relevant custom properties. One is machines per storage account. By default, it's 40 VM per storage account. It is based on the 500 IOPS per VM allocation, because each storage account will give you 20,000 IOPS at the max. And then the storage account per resource group is default to 10,000. So those are the default value. You could change, but we recommend you don't change, based on the best practice recommended. One more slide about Azure Managed Disk. Now, Azure Managed Disk is the one that we are moving forward, as I said before. But historically, because unmanaged disk was the first one that Microsoft introduced in Azure, and also that's how we implement our first version of supporting Azure. So therefore, unmanaged disk is actually a default disk type. And we are changing that, right? We are now changing to use managed disk as default as true. So all this will be created as managed disk. And because of that, we actually have to change schema version so that for all the new prop scheme created, they will be using a new schema version, which is 2, and the previous one will be the 1, right? So if you don't say anything, the disk will be by default created as managed disk. If you want to create unmanaged disk, you actually have to explicitly specify. And a schema version that I'm showing here just as an example, they're actually not the custom property. They're their version of the prop scheme. MCSIO, this is actually a pretty big feature. It's a very unique to Citrix. We have our own way of caching, and it is a cost and performance trade-off. And in some cases, it's both a cost and performance improvement. But in some cases, it will be a trade-off. Now, let me explain why I said that. For example, the write-back cache disk can be persist. It could also be deleted and shut down and recreated at the boot. In the case of if you want to preserve some of the data, for example, event logs, crash dump and those kind of stuff, then you may want to persist the write-back cache disk, because that's the disk you can redirect those content to it. Otherwise, if you leave them on the OS disk, if it's non-persistent VM, when it goes through a power cycle, you will lose all those, right? So persistent write-back cache provides you that capability. And then next one is the persist OS disk. So because we have write-back cache disk capability, it means all the IOPS are written to the write-back cache disk, and therefore the OS disk is actually not changed. And because of that, OS disk is always clean. And therefore, for a non-persistent VM, there is really no need to reset the OS disk. Other than if you shut down your delete OS disk, you save your storage costs. However, you have a choice now to persist that OS disk. If you persist the OS disk across power cycle, then you will avoid the disk hydration. And the disk hydration is a terminology that we refer to cloning the disk, right? Every time for non-persistent VM, the normal behavior is that when you shut down the VM, we delete the OS disk, and when you boot up the VM, we actually recreate the VM and recreate the disk by cloning from the master snapshot that we published. And because it's cloning, it takes time to copy all the bits from the master published image to the newly created OS disk. And if you power up a lot of VM and then basically create all of them at the same time, it means that a lot of cloned disks are all copying their content from the same published image, right? So that is called the disk hydration because they're competing for I/O. All your VM booting up can be slow. Even they boot up, when the user log in, if they try to access the application bit's still not there yet, and they're still being copied, right? Every VM, every OS disk is competing for that, bandwidth for the master image. And and so that helps you to avoid this hydration, because if you're not deleting it, you have the OS disk, have all the contents, you boot up and read locally directly. Now, with the capability of persist OS disk, now you actually can persist the VM. What's the value of persist VM? One of the key advantages is that the VM will always be there, right? For non-persistent VM, we are following the methodology of on-demand, meaning that if you power off the VM will be deleted. And then when you power on, the VM will be recreated and power on. So actually, if you go to the portal, if you shut down all the VM, you don't see any VMs. If there's a scenario, if there's a outage case, for example, then you won't be able to see any VM. You won't be able to actually say power up from the studio, right? But you could, with this feature, you can go to the Azure portal and be able to power the VM directly over there. And then even as you power those VM actually are coming back clean, because the IOPS are written to the write-back cache disk, and they got reset at every OS boot. And lastly, we're introducing new features to further enhance MCSIO to reduce the cost. As you can see, we enable you to use temp disk for write-back cache. So instead of allocate a write-back cache disk from a managed disk and paying the cost, you could use a temp disk if the VM size offers temp disk, and you can use that to cache all the IOPS. So the write-back cache disk, you will get that for free. And then, of course, in those cases, you have to also decided how much you need to allocate for the page file, right? Because the page file is actually by default for Microsoft, it will redirect to the temp disk. So you want to make sure that you have enough space. You reserve the page file space, as well as for the write-back cache file. So on the right-hand side, you see a picture. It describes the relationship, right? So if the use at the top is the use write-back cache is true, then you have a choice to, excuse me, to persist OS disk. And if you persist OS disk is true, then you have a choice to persist VM and so forth. This one is Azure Shared Image Gallery, and it's about flexibility, provide you flexibility to balance cost and performance. For example, by default, use Share Image Gallery is false, but if you set to true, MCS will create a Share Image Gallery and create an image definition, and will set a version to be 1. And so now you have an image in the Share Image Gallery. And then there's two parameters that will define the characteristics of this shared image in the this image in the shared image gallery. First is the ratio, the replica ratio. So Azure Shared Image Gallery provides you a replication capability. There are actually two replication. One is replicate to a different region, for example, but that's not the one I'm talking about. I'm talking about replica locally in the shared image gallery in the region where you created. Why we need that? Well, if you remember back when I talked about previous about MCSIO, when you put the VM is all trying to copy from the master image, right? The image that we going through the image prep and create that image. So everybody is competing, reading IOs, doing cloning bits, and that single published master image is now a bottleneck. By providing a replica, we basically can load balance the IOPS request across the replica instead of a single one. So the default setting is 40 for non-persistent VM and 1000 for persistent catalog. Meaning that, for example, if you have 40 VM, you will just have one image that we created in the shared image gallery, as I explained in the previous bullet. But let's say you create a catalog of 80 VM. That means that we actually will make two replicas, right? So one is the original created one. We'll create another one. So in other words, there are two now images in the shared image gallery. Now you from the VM standpoint of view, from all those newly created VM, they only see one single image. Behind the scene, there's actually two images at the storage level. And Azure will take care of the load balancing and try to help you to get the most bits read out of those two replicas. So if you say you are creating 120 VM, now you will have three replicas, right, at the storage level. So you basically have three identical disks representing the OS image, and that will service all those 120 VM reading requirements. And then there's a shared image gallery replica maximum. There is a limit, though, how many you can create. Today, the default is 10. Microsoft is working on increasing that number. And we actually make this as a configurable number so that whenever Microsoft decides to increase that number, you don't have to wait for us to release the software to increase that maximum number. So we allow you to set that to whatever number you want to. However, let's say today you set it to 11, you will probably, the 11th one creation will probably fail because that exceeded the Microsoft maximum, right? But if tomorrow Microsoft raise that to 20, you'll be able to create 11, 12, and so forth up to 20. Next one is on the encryption and ephemeral OS disk. So this encryption set ID is used for server-side custom managed encryption key, generally called CMEK. The ID needs to be in the same region where you want to create your VM, and please note that it cannot be modified. So it will you set it to the beginning of the calculation time. You cannot change that. It's actually a Azure limitation. So we basically check for you to make sure that we don't allow you to change. Even if we allow you to change, it doesn't actually matter, because if you change the new ID, the new VM creation will fail because it's no longer matched. The ID itself cannot be changed. Next one is about ephemeral OS disk. This is a fairly new feature that Microsoft released. It basically means that there will not be OS disk visibly allocated to you. You will actually use a cache disk whenever it's available, and use that local cache disk as your OS disk, and that the disk will read the content from the published master image. So it will definitely speed up the hydration and the VM boot up because it does not need to go through the additional hop in the network storage side for if you have your own managed disk OS disk, right? And then so it will go directly reading the master published master disk. However, not all VMs support that. A certain size VM does not support FemOS disk, and the other one is that your cache disk need to be at least as big as your OS disk, right? So there's some limitation. Please be aware of that. And then we are working. We actually completed a feature, but waiting for Azure to GA, where if cache disk is not available, but temp disk is available, or cache disk is not big enough, but temp disk is big enough, we will actually use the temp disk for the FemOS disk. And lastly, please pay attention to the disk usage as you patch and upgrade OS disk, because your OS disk is going to grow, and if it's grow bigger than your cache disk or temp disk, then your VM image update will fail, and that could be pretty bad. But we do check as part of the image upgrade. If we find it's bigger, we'll fail you. But yeah, then the challenge is that you already set it to a FemOS disk, right? The catalog is already a FemOS disk. You can't really change it. The only way you recover is actually recreate a catalog of a different type. So, and then of course, there's actually a choice changing the sizes if you can find a size that's bigger enough to fit you, but it will only be available to the new VM. Existing VM will not work. So yeah, there are a number of small gotchas, so to speak, for the FemO disk, so you need to be careful on that. And there's some miscellaneous Azure properties. Resource group. If it's empty, it means that we, MCS, will create a resource group. If it's not empty, then admin will supply. And today, we only need you to supply a single resource group because Azure changed removed the limitation of the object quota. So it's now unlimited as far as the compute is concerned. So it's practically unlimited VMs to be created in the resource group, so there's only need to supply one resource group. There's also license type, Windows Server, Windows Client, and empty. Please be aware that license fee will be charged if it's empty. If it's set to Windows Client, if it's desktop, there will be no license charge. If you set Windows Server, it means you bring your own license, your Windows Server's own BYO license, then there will not be a license charge. Of course, then bring your own license means you pay your own license already to Microsoft. There are other license type, the Red Hat and the SUSE BYOS are in the roadmap. And in terms of OS type, today there are two types, Windows and Linux, and default Windows. And then dedicated host group is another one. It's about supporting a dedicated hardware when you run Windows. Typically, you use it for several purposes. One is for security reason, that you want to make sure that your VM only running on the hardware that you manage, or because of license requirement that you have to run a dedicated hardware. Please be aware that the hosts need to be enabled for auto placement, because we actually don't explicitly place VM to any specific host. We let Azure to handle where they want to place the VM. So hosts need to be enabled for auto placement. And the last one is the zones. We accept you to provide a list of zones. It could be one or multiple. If it's not empty, then we will randomly place the VM across those zones. But if you leave it empty, then we will leave Azure. So there's a pros and cons in both approach. If you leave empty, then Azure will decide where is the best in terms of resource availability and capacity. So it is less likely that you will fail because you cannot find the capacity. However, it is also more likely that all your VM may be placed in the same zone, versus if you specify all the zones, we will try to randomly place them across those zones. And at the end, statistically, they will be more or less evenly distributed across zones. But of course, if the VM that you specify is not available anymore, run out of capacity in the zone, then it will fail, right? So it will not be able to create in that zone. So your VM creation may be failing, and your capacity may not be as full as you initially planned. So there are pros and cons. We'll keep that in mind. Next one is on AWS, and then I'll talk about GCP. Both of them are pretty thin. The Azure by far has the most custom properties. AWS, we have two. One is the capture instance properties. By default, it's false, but if it's true, we will capture VM tags and IAM roles so that we will place the VM tags and IAM role to the newly created VM in the catalog. Today, the behavior is that we need that VM actually. So if you just say AMI, then this feature will fail because we actually need to capture that from the VM, not from the AMI. So the way we look at it is you supply AMI, and we look from AMI, we look for a snapshot, and we look for volume, then we eventually trace it down to a particular VM. We will capture the tags and IAM role from that VM. If you enable the operation resource tagging, then it means that not only we will passing the tags and IAM role to the newly created VM, we also will pass the tags to all the resources that we create as part of catalog creation, such as this network interface, S3 buckets, right? You name it, all the resources basically we created. The purpose of that is to enable you to trace all the resources, regardless it's the operational resource, transient resource, or the end result resource, which is the VM that we create. You can track all of them based on a specific tag that you put on your master image. And lastly, GCP. So also we have two properties here, catalog zones, and it's very similar to Azure zones, where you can provide one or multiple zones. If it's not empty, we will randomly place across specified zones. If it's empty, we leave GCP to place. Crypto key is also similar to Azure. It's a custom managed encryption key. It's a CME key that supported on GCP. And then when empty, basically this is using GCP system managed system encryption key. It's basically encryption at rest, right? That's the same as everywhere else as Azure and AWS. So if you don't specify, it's encryption at rest. If you specify, then it will be the key that you supply. It will be encrypting the data encryption key for the disk. So it's like a key encryption key of the encryption key. The only caveat on this one, GCP actually, is that the key changing is quite it's a little bit more complex. It's not automated if you want to change the key, versus Azure. Now, as I mentioned, Azure, the case is encryption key ID you cannot change, but you can change the key. The ID is basically it's like a container reference to the key, encryption key itself. Whereas in this case, the key in GCP is actually locked down. So, but if you, for more detailed information, please refer to our documentation or give you step-by-step instruction on how to switching the keys. Okay, so that is the end of my presentation, and thank you for your time. I hope it's valuable and useful for you to help you to understand what the custom properties are and how they work, and provide you provide some assistance to you to create tools and maybe automation based on our PowerShell command. Thank you.